Hello good people, I'm going to talk about charts and graphs. The terms charts and graphs in everyday language are often used interchangeably. That is because they are both used to visually represent data, but there are differences between the two. I'm going to focus on charts first. They commonly involve categorical and discrete numerical data. What are those? Well, let me explore an example. Suppose that we have asked a number of people about their attitude towards mathematics. And it turns out that their attitudes could be grouped or categorized into following, categories. Some of them think that mathematics is totally heavy metal. Others love it loud. Some think that mathematics is the stairway to heaven. Others think mathematics makes them paranoid. Some think mathematics is poison. And some believe that mathematics is a highway to hell. Bonus points to all of you who get the references here. How could we represent this data? One way is to use a bar chart. We are going to construct our bar chart by starting with the x-axis. This is the horizontal line at the bottom where we place our categories, and here they are. The y-axis, or the vertical line, will contain the numerical data. In this case, the numerical data represents the number of people. And now I'm quickly going to draw bars that represent the number of people who fall into each category. With this bar chart, it is much easier to get a visual sense of what we have. Depending on how hard it is to read the intervals on the y-axis, it is also considered good practice to add the actual values on top of the bars. Speaking of values, earlier I mentioned that when we construct a chart, we are usually dealing with categorical and discrete numerical data. The categorical data in this case are the categories for the attitudes about mathematics. Now these categories could have been something else, such as favorite pizza topping, favorite color, the most preferred position that allows for the best, or maybe your favorite sport. Those are all examples of categorical data. Discrete numerical data, on the other hand, are a result of counts or observations. Usually they are whole numbers. In this example, the discrete numerical data is the number of people. And it makes sense that the number of people should be a whole number. Outside of some choice horror movies, we cannot have 0.7 of a person. Finally, to make everything spick and span, it is always good to also include a chart title. And here it is, people's attitude towards mathematics. Now, a bar chart is not the only chart we can use. Pie charts are usually used when we represent our data as a percentage. So the whole pie, or the whole circle, represents 100% of the data. In our example, 12.5% think that mathematics is heavy metal. 25% love it loud. 20.8% think it's the stairway to heaven. 16.7% feel that it makes them a bit paranoid. 8.3% insist that mathematics is poison. And finally, 16.7% believe that it is highway to hell. If you are representing your data in terms of percentages, it is always considered good practice to also give the total. In this case, 360 people. That would be 100%. Okay, that was a short introduction to charts. Let me now turn my attention to graphs. How are they different from charts? Well, we still use graphs to visually represent data. However, we tend to use graphs to represent continuous numerical data rather than discrete or categorical data. In short, continuous numerical data depends on some sort of measuring instrument. Also, continuous numerical data can be sliced into ever finer pieces. Suppose that we are monitoring the height of a gum tree over time. If I'm going to track the height of this gum tree over time, what are the variables involved? Well, there is the height, and then there is time. Two variables. And luckily, we have two axes. On the x-axis, we will place the independent variable. This is often known as the cause. In this particular case, that is time in years. The y-axis will contain the dependent variable. In this case, that is the height in meters. The dependent variable is sometimes referred to as the effect. What does this mean? Well, let's think about this. Unless time passes, the tree cannot grow, whereas time will pass regardless of whether the tree grows or not. The height or the growth depends on time, whereas the time is independent of the height. So let's assume that we have tracked the height of this tree over a period of 10 years. And these are the data points that we have collected. At year 0, when we begin tracking the height, the tree is already 2 meters tall. After 3 years, it is 6. After 8 years, it is 14. And after 10 years, it appears to be 16 meters tall. As was the case with charts, it is considered good practice to give a title to your graph. It does not have to be anything fancy. In this case, it is simply gum tree height versus time. Each of these points that we have collected represent a measurement that we have made. And each point comes with its own coordinate or ordered pair. So for example, this point here is 3 on the x-axis and 6 on the y-axis. Therefore, its coordinate is 3, 6. By the same token, this point up here would have a coordinate of 6, 10. It is 6 on the x-axis and 10 on the y-axis. Can these points be connected by a line? And the answer is yes. So let me do that. Now you might be wondering, why is it that I'm allowed to connect these points with a line? Well, that is because this is continuous numerical data. The height of the tree changes continuously. We don't magically go from 10 to 12 meters. The tree had to experience all the heights in between as well. By the same token, when it comes to time, we don't magically go from 6 to 7 years. The time in between needs to pass as well. This is what I meant by saying that continuous data can be sliced into ever finer chunks. Yes, the height could be measured in meters, but I could also measure it in centimeters, then millimeters, then nanometers, then picometers. And the same is true for time. I could go for years, months, weeks, hours, minutes, seconds, milliseconds, nanoseconds. Now, why is it that we enjoy graphs and charts so much? Well, aside from looking neat and giving us a visual representation of the data, they can also be used as a tool. Graphs allow us to obtain values for points in time where we did not actually make the measurement. Based on these points, I have only made a measurement every year. But I might be wondering, what was the height of this tree after 8.5 years? By reading the graph, I can obtain that information. So firstly, on the x-axis, I go to 8.5. And then I go all the way up until I hit my line. And now I go all the way across until I hit the y-axis. And it would seem that I hit the y-axis somewhere between 14 and 16. I admit, for a better reading, I should have constructed a better graph with better intervals. But because we are all friends here, I think you can forgive me and accept that it would seem that after 8.5 years, the tree was 15 meters tall. Finally, when it comes to constructing your graph and drawing your axes, note that the distance between the intervals needs to be the same. In other words, the intervals need to represent the same value. So in my case, on the y-axis, each interval represents a change of 2, whereas on the x-axis, each interval represents a change of 1. All right, you have earned your break. Go sit beneath a tree and ponder the finer things in life. That is all for now, and I will see you on the flip side.